Hi everyone, this is Vlad from Alephium. Welcome back for our Tech Talk number 10. It's a real pleasure to have you and it's a pleasure to be back. Tonight, we have a very special guest. I present to you Alexis Roussel from NYM.
Hello, hello
he,
everyone.
the session will be as usual. I'll do a short introduction and then Alexi will present him a little bit for those who don't know it really well. And then I'm going to ask him a few questions, and then we're going to open the questions to everyone. So if you have questions, you can always put them in the chat. We will collect them, and I will ask them later on to Alexi. We have a good full hour for us, so don't worry. We'll have time to ask a question. And if you have a few questions about Alephium, we can talk about it in the end. So without further ado, I will present a little bit Alexi, which I'm happy to call a friend. He holds a master in technology public law. He has served as an e-governance specialist for the UN. He's the co-author of previous our precious digital integrity book with Grégoire Barbet, and he's a tireless campaigner, explainer, talker about the importance of having digital integrity and to protect the ability for people to control the data that they generate. He is one of the pioneers of the Bitcoin meetups in Geneva, where I had the pleasure to meet him back in almost 2013. And now, after having also been the president of the Pirate Party of Switzerland. He is also the co-founder of BT, which is the first or second broker of cryptocurrency in Switzerland. And now he's the CEO of NYM. NYM, you might have heard of it. It's this amazing privacy project that is kind of geared to be the new Tor, better Tor, but I will let him explain. Alexi, I think your camera has disappeared and now I see you back again. You can also unmute yourself, and now I am gonna let you talk about this amazing work you do at NYM. With also, I have to mention, like the people you work with are like gigabrains, as they say in NYM parlance, like Harry Halpin, and Diaz and the others. So, without further ado, Alexi, I leave the
Thank
floor for
you,
you.
thank you. Thank you, Vlad. So he forced me to make a presentation, so I couldn't make a presentation. So let me start off this small. I have a few slides to explain a bit what NIM is. So first, thank you very much, Vlad, for the introduction. Indeed, I think the general gist of the whole my whole view is how to build a digital society that makes sense for the human being. I just want to be a human being using all the technology around me and benefiting from this, but kind of like keeping myself human in the middle of this, and not becoming alienated and losing my ability to make decisions. So that's a bit the way I see things, and I think crypto is a field which is touching on that specific things because you're in control of your keys, and it's a key element, and we're building public infrastructure. So I think there's like a lot of elements which make sense in that regard. I come from the privacy world. I mean, I come from the e-governance world, from this how technology is used by society. I come also from the open source world. I was very much into all the open source and privacy movement in the late 90s and early 2000s. And as Vlad explained, I started in the crypto side because I thought, that's my feeling, that crypto is actually built on the things which matters for the digital society, specifically Bitcoin. And then now I had the chance with NIM to join both things again, which is working on privacy in the crypto world. And so that's the magic combo for me, which then allows me also to work on the digital human rights that Vlad was talking about. Um, so let me share my screen, and so please bear with me because there will be just some. Um, Here we are, and I can do the slideshow. So Vlad, can you confirm you see my screen correctly? Vlad, you see my presentation?
Yes, I see your screen
Uh,
perfectly. We don't see you, but
uh,
we can hear you, which is the
you
main
don't
thing.
see me. Okay, that's fine. That's fine.
Then we
Okay,
can hear
so
you, and then we will see
you
you
can hear
again.
me. Okay, perfect, perfect. Okay, so what I'm going to talk, it's a very short
Yes.
presentation, and I know the audience here is highly technical. So and basically, most of you here know already the environment. So I'm going to skip a lot of talk about what the crypto environment is or what the privacy environment is, because I mean we can talk a bit after in the discussion, but I think I would assume that most people in the audience are aware about cryptocurrencies, blockchain layers, cryptography, and incentive mechanism on one side, and on the other side you are mostly aware about privacy and how privacy is built and why privacy is needed. But we'll go back again in this, I think, in the discussion after. But I'll take this assumption. So we go deep dive directly into NIM, what is it proposing. So NIM is a mixnet. And I think this is a key. This is the key element, the mixnet, which is until now in the tool set of privacy. If you want to build privacy around you, or if you want to use tools that are privacy enhanced tools, um, actually the mixnet was one of the few tools which were not available until now. Where does it come from? The mixnet has been designed or theoretized in the 80s by David Shawn. So it's a very old concept. And the idea of the mixnet is to have a network of computer that collaborates between themselves in a very specific way, and we'll deep dive in how they collaborate. And because they collaborate together, they create a communication network. And when I'm sending a communication through that network, then my communication becomes unobservable by a global passive adversary. So a global passive adversary is someone who can play God mode on the internet, basically. So someone who has enough power, computing power, and access to enough networks that it can actually see how the internet traffic is moving from one side to another of the internet. And uh, it was at the beginning very limited, very costly, and very hard. And while internet has been growing, basically, we saw that first only like huge institutions like the NSA or some similar type of institution were able to play God mode, but with time, we see that the cost of this is lowering down very rapidly. So, so that's what a mixnet is, and why is it important in the scope of privacy? Is that privacy is not just about the content of the communication. Privacy is also about the information about the communication. So if I send a message to Vlad on whatever Telegram, um, by knowing the fact that we are discussing, even though we are using a encrypted way of communicating, if we enable it on Telegram, then uh, indeed Telegram cannot see what we're saying, or Signal is not able to see what we're saying. Someone who is observing the network would still be able to see that I'm talking to Vlad, right? And based on the timing, based on the frequency, based on the pattern of communication, um, we can defer, we can kind of deduct in a very precise way the content of the communication. So basically, uh, hiding hiding the content of the conversation is not enough. You need to hide also the knowledge of that the conversation is taking place, and that will uh, allow a good level of privacy. So basically, if you have a transparent network, if you want to have a good privacy system, you need a layer that is creating so much noise that you would not be able to see those communications happening. And the first use case that we have is going to be crypto transactions. This is a very easy case to understand for the community here. Basically, if you are observing the network layer, if you're observing how Bitcoin or Alephium or um, uh, even Monero type of networks, if you are looking at the servers, which are the nodes which are broadcasting the transaction, who is connecting to those nodes, and you see which wallets, what is the IP address of the wallet connecting to a node broadcasting a transaction, you can see that happening on the network level. You might not, you might, the transaction itself might be obfuscated, like on Monero or Zcash. In Bitcoin, it's more transparent, so you could immediately link a transaction with an IP address by watching the network layer. So a lot of people are working on privacy inside the blockchain, inside the transaction with ring signatures or with rollups, but the network layer is always giving away a lot of information, and so we are coming at that place. So that's the NYM mixnet, and we'll deep dive in how the mixnet is actually performing this function. On the side, and this is what is of course new in the world of our infrastructure, is now we start to have business models that can sustain public infrastructure. So and this happens through means of tokens. And the idea of the token is it will create a reputation system for the servers which are running the network, the mixed node, and it is also a way for the economical incentive to happen and to have the users of the mixnet or people who want to give access to some other people who are actually paying for that access. So the token is going to incentivize, and the price of the token, we can talk a bit later, we think will be based on how much do I think 1 GB of value of traffic on a privacy network is actually worth. So um, uh, that's the part of the token. And the third part is the credential. The credential, this is also a very novel part, which is still right now not very visible on the Nix in the Nix environment, because we're focusing on building the mixnet and having the token work with our infrastructure. But basically, the credential is a zero knowledge proof that is issued by the part of the network, and in order for you to you can pay to use the network, but if you would just pay for using the network, we could relate that we could see that you are the user of the network. Let's say you're using a VPN and you're pay with your credit card. You pay with the credit card. The company who is running the VPN and accepts your payment, even though you might not give away your name while you're using the VPN, they know that you're the one who paid, right? They need to check who you are. They know they can trace. There's a trace with the payment. So the idea of the name credential is to allow unlinkability between the payment and the usage of the network. And for this, when you are paying for some credit, you would receive a credential, and this credential has a very specific um, characteristic that is a novel characteristic. So it's a zero knowledge proof, which has the proof that the, that that we the traffic was paid for. But then this proof can be randomized locally on your own machine, and it can be randomized as many times you want. And when you present this proof to one of the gates of the network, basically there is no way for the one who receiving the proof and the one issuing the proof to collude and see that it's the same proof that was provided. And so they cannot correlate who you are between the person who has paid and the person who is using the mixed node. All right, so let's go now a bit deep dive in the mixnet itself. The mixnet, and after the presentation, Vlad, if it's okay, I'll just show also the Explorer, because then we can see the real thing happening, and I think that's pretty cool because it's a live network right now.
Yeah.
So the mixnet itself is a series of computer, and I will show you the graph afterwards. But it creates some work. It does some work on the traffic that goes. So you're sending traffic in there, and there's some work that is being done. So first, before you actually send the traffic to the network, your client, the NIM client, will put the traffic inside what we call Sphinx packets, and soon it will be called Outfox packets. And those packets are standardized, and they all have the same size. So right now, I think currently they're 8K size of packets. And because, and this is the first level of protection, is that every user in the network will just send packets from the same size. So it doesn't matter if you're sending a video, or if you're sending an image, or you're sending a Bitcoin transaction, which is 200 bytes long, whatever. It doesn't matter. You are sending an 8K packet or several 8K packets. And there is no way to make a difference between someone who's sending a Bitcoin transaction or a picture. These packets are also designed to have the onion routing built in. So actually, they are encrypted in three layers, and they move through the network a bit like Tor. So this is very similar to Tor. The packets move through the network using 3 hops. And so basically, the packet is encrypted first with the last server's public key, and then with the second service, second server public key, and then the first one. And then when the packet is sent, only the first one can decrypt, and the second, and the third. But unlike with Tor, the packets, every packet is using its own route. So in Tor, you would have a stream of data that will move through 3 selected servers, and then you would have the encryption. You would always use those 3 same servers for, let's say, 5 or 10 minutes, and you can change that manually in Tor. But in NIM, by design, every packet will take a different route, though that means that there is no single server on the mixnet that actually knows the entirety of your traffic. So the second point is about cover traffic, because obviously the guy who's sending just a Bitcoin transaction needs to send 1 packet. If you're sending a picture, you might send 10 packets or 100 or 50 packets. So what happens is that your client is also producing cover traffic, which are indistinguishable packets, which looks the same but are just fake, and are being sent through the network to create some noise. And there's about 20 to 30% fake traffic. Then the third part is that the inside the packet, every time a layer is opened by the mix node that is receiving the packet, the mix node, there is a header. There's a header inside the packet, which includes some data, and specifically it includes a timing data. And so the packet is opening the onion, reads the header, and it says you have to delay this packet from 0.1 milliseconds. And actually, the server has to slow down the packets with this number. And at every layer and at every packet, those numbers are different, are uh, somehow randomized, but it's maybe not really randomized, but basically those they're all different, which means that when the packets are coming on the other side of the network, they have been shuffled like a deck of cards. So you can imagine that if I'm sending packets, I'm distributing packet my cards to a different numbers of nodes, and every user is distributing his cards to different nodes, and then every node is shuffling the cards that he gets, and then sending them to another nodes, and then again the mixed node is shuffling the cards, and when the packets arrive on the other side, they don't have the same order, and you cannot make what is called a timing attack, which means you can try to correlate. By observing the network, you can see, oh, if the packet goes in here and the packet goes out at the same time or almost at the same time with a certain delay, well, I can assume that because of how the speed of light, how the network, the fiber works, I can assume that these two computers are the one who are talking to each other. And this is one very specific attack of Tor, where if you control the entry point and the exit point, you can, by correlation, not only by the timing, but also by the patterns, you can see who is talking to who. So here the idea is that the server, when it receives the packet, has no clue to where the the person who has initiated the packet is actually located on the network. And then I will come to the last point, which is the structure of the network is different. And the structure, it's not a peer-to-peer network that we are used to. Peer-to-peer networks are really good for a lot of things, but in our case, in order to have scalability and in order and also in order just to provide the right level of anonymity, we don't need a peer-to-peer network. We can use a layered network. So basically, you have three layers: layer 1, 2, 3, and a packet will always go through a mixed node from layer 1 to a mixed node of layer 2, then to a mixed node of layer 3. And when you have such kind of infrastructure, right now we have 240 nodes, which means we have about 80 servers on each layer, right? Then what you can get is you can get horizontal scalability. So the more you add servers, so every time we add mixed nodes, we would add 3 mixed nodes, in one in each layer, right? And basically we can augment the throughput of the network in a linear way rather than in a pure peer-to-peer system. If you are scaling the system at one point, the network, if the network the discoverability in the network becomes more difficult, and so you have it slows down the network. So a lot of people use, and even Vlad presented NIM. Maybe he said like a better Tor. I would say it's not like a better Tor. It's a different thing than Tor. But there are some things which are similar. So here are basically the comparison with what people understand, right? In terms of privacy and networks, people come from a very specific world where we have two main tools which are available: the VPNs and Tor. And mixnet is a different kind of network. And which we think fits a very specific purpose. So a VPN is very simple. You are routing traffic through a node, and this node is actually controlled by someone in a data center. It can be controlled by a private company, or it has to be controlled by someone. And this person knows exactly where you're from, where you are sending data from, where you're sending data to. And someone who observed the network can also see that there's some traffic coming in, some traffic coming out, and this traffic are correlated. It's the same type of traffic. So Tor is a bit different. Tor, you have this onion routing where you are selecting a path through a peer-to-peer network, and but in reality, this path has been designed for for speed, and has been designed to change every 5 minutes. And so the role of Tor was to make sure that there is no way for people in the network to know what is your IP address. So that provides a decent amount of security here, which is that indeed um, uh, maybe we can correlate. At one point, someone can still trace you with fingerprinting and few stuff, but the IP address is well hidden from the server. The client IP address, your IP address, is pretty well hidden from the server you're connecting to. And then you have the name mixnet, which you can see here. We have those 3 columns, 3 layers, and there's so you have to imagine there's 40 servers right now in each of those rows. And here we go into a more deep dive. You are using on your machine a client which transforms those packets, your internet traffic locally. So on the side, you still have like traditional TCP/IP or UDP packets, which are inside your machine, are being transformed into Sphinx packets. They all have the same size. It goes into the mixnet, which does all the work with the onion routing, with cover traffic, with time obfuscation. So it's the shuffling. And then when the packets go out, they still have the same. They have a different form because they have been the layers of the have been peeled off, but at the same time they're not in the same orders. And then you can talk to any backend servers that you want. All right. So now I'll give you like a very good example. We just released it, and I think this is the closest example, that a very good example that we can use for Alephium in the discussion, is that for a cryptocurrency project, which basically is based on certain tools, right? So you have um, validators or miners, basically people who are running the network nodes in the Bitcoin world, validators now in the Ethereum world, and and basically they built a peer-to-peer network, right? And then they have some functions. You can be a miner, you can validate, you can be part of the consensus network, or you can just be a node that broadcasts and wants to read the network. Whatever, doesn't matter. You are part of the peer-to-peer network, and your role as a server in that peer-to-peer network tells a lot about you, right? And you can be a target, right? If you're a validator on Ethereum and you have a lot of stake, people maybe want to see you slashed. If there's competition on Alephium proof of work system, maybe some people are happy to attack you, so you're not able to. They make a kind of DDoS attack directly on your IP address to avoid you. Um, uh, uh, to avoid broadcasting the new block or the new consensus, basically. So here the idea is that we had this very specific project where inside the libp2p is a library which is a lot used in many crypto projects that allows peer-to-peer communications, and we added a NYM client within the libp2p. So the idea is that in the future, a peer-to-peer network like let's say Alephium or Ethereum validators, they could just enable between themselves NYM, the traffic going through NYM, and they would lose a bit of latency, but then they would be able to participate in the consensus mechanism without revealing their IP address, but without revealing their location, the actual location on the network. And that could actually protect them. So that's one example. There's also an example of wallets. You can also we've been working on integrating NIM into MetaMask. That's one example. But we also, I'll show you some cool example of how NIM is integrated even within a website. So um, I'm going to switch. So thank you very much. So that was a presentation. Here are some links. I think Vlad, you're going to share those links in the channel. And so we have our GitHub account. You can go there. Our Twitter, follow us there. You get updated with our last. I know it is twice GitHub. Now I see that. So there's a Twitter account. You're also sharing our Telegram account and our Discord account. So thank you for this. I'll just switch to now this. I hope you still see my screen, but
Yes.
uh, you still see my screen. All right. So I'll go to the
No, no.
website.
Yeah.
Yeah, you see the
I'm.
website of NIM right now?
Yeah. It's coming.
Okay, perfect. So what we have the name Explorer, right? And that shows you that we have this is the map of our nodes. And basically, I mean, there's a lot of countries which are still empty, but basically we have right now 240 active nodes out of the 600, and basically those nodes, if I click on them, it's actually a node which is running, has a certain type of characteristic. It has some statistics, some performance. It is active. It has a routing score. Is it able to route well the traffic? It has a location. So what is interesting is that the mixed node themselves have to be very transparent. So in order to protect the others and to provide anonymity to the others, you have to be very transparent. And basically, there is even a what we call Verilog. We're going to verify the locations that you are claiming to be. So if you're in Brazil, that is going to be actually be verified that your IP and your machine is actually physically uh, on the network level around the region where you think you're telling. So so that I urge you, I propose you can have a look at this map, and then I show you another example of how NIM can work. NIM can work into a website. So here in the case, I'm using a website called pastenim.ch, which is done by our community. And basically, what I just did here, I connected to this website. I downloaded a bunch of assets of JavaScript assets, or in this case, more TypeScript assets, including a NIM client, which is running now inside my browser. So I have here a client ID, which is connected to one of the gateways, and I can put some tests. Hello to Lithium team or community, and just to make sure that there is no I would say tricks. Vlad, can you give me one word that the community is going to paste now in the channel in the text? So you give me, so someone in the community just say something and one word, and I will put it there. What is it?
What do you mean? Like, just why don't you
I
put
want to
a
I want a secret. I
no,
want
no,
a
put
secret word.
a secret word. Like you can put like a proof of less work.
Yeah, but it's you. I could collude with you before the game. I mean, I was. If it's someone from the community in the channel can say something, that would be more fun.
Okay,
Anyway, proof.
someone like Cheng can put a word in the chat, or Oheka,
What does he
or
say?
even Montail. The thing is, they have a 20 seconds. Yeah, okay. Zapoy is proposed.
Ah, Zapoy. Okay, Zapoy. All right,
Okay.
here we are. Okay. So anyway, so now I'm going to send it, right? And now the text actually went through the mixnet, and someone observing the network did not see any traditional HTTP traffic. It just saw some traffic going on the mixnet. I'm going to copy this for you, and you can share it in the community, and they will be able to view that text the same that we are that we just shared now. So yeah, I think we also have a cool test which is called NIM Connect, and this is also something you can try to use. NIM Connect, sorry, NIM Tech. And if you go on the website, you go on the download page, and here you have, so the wallet is to use to interface with our assistant, but the NIM Connect is quite interesting because this is a small applications which you can run on your desktop. We have a mobile version which exists that you can download illegally from our channels. And then you can connect Telegram, for example, through the mixnet, or you can connect Electrum, or you can connect Monero wallets through the mixnet. So maybe that's a good game that we can do, is to connect Alephium wallets also through the mixnet. Yeah, and I think that's it. I'll come here and I stop presenting, and I hope. I mean, 40 minutes. Your 20 minutes are gone. I'm sorry.
It's fine. It's fine. I mean, you actually answered like half of the questions that I had prepared, and so it's fine. It's perfect, ladies. It's very interesting. Like my first question is like you haven't detailed it completely, but you are clearly an activist at heart. You
Yeah.
clearly have a vision for society. So my first question would be, what is the use case? Why do you think this is important?
Yeah, so it's important. So because I think that the only way to build a true democracy or true humanist society in the digital space is by having people who are in control, who are um, able to make their own decisions, right? And uh, it is proven that if in the digital space there's some different mechanism. If you walk outside and you are in the society and you are in the nature, you talk to people, um, the nature is very hard to change around you, right? To manipulate you, people need to talk to you to convince you or to force you into something. But in the digital space, your surrounding, based on your profile, can be transformed, and you are not aware that your digital surrounding is completely changed, adapted, manipulated based on your profile, and that changes your perception of the world, and it changes your way to decide of things. So this is Cambridge Analytica. This is a simple example. Um, Now, so how do you stay in control? And in order to stay in control, it's not about being in control of your data. I think the way to stay in control is that to have a default, a baseline of being totally anonymous on the network, that you as a human person, you are not providing any data, and then only when you want to interact with people, or then you would selectively disclose what you want to share. But a government, for example, should not be able, or any new type of infrastructure, social infrastructure that we will have in the future, in order to respect you as a human person and respect your ability to make your own decision, needs to make sure that they know the least data on you. And so when we talk about the right to digital integrity, one of the one of the element that comes with it is the right to use cryptography, or the right to not to be surveilled, not to be analyzed, and not to be measured. Because there's a bit of like quantum physics, right? As soon as you look at something, the state is changed, right? So, and in privacy, it's in your ability to take your own decisions and to participate in the society is the same. If you're being looked at, you'll behave differently. That's
So,
instant.
s-
So
so you,
here we have the technical tool to do the same construction.
so you've perfectly answered the why do you think it's important? What do you think is the first use case? Very briefly,
Oh, the first use case for us is cryptocurrency transactions, right? Because this
cryptocurrency
is where
transactions. Yeah.
because there's like now there's huge amount of work being done by companies like Chain Analysis, selling out the data to agencies, and you already have financial agencies or even tax departments that instead of doing their normal work, which is, oh, we find out that someone has been doing something wrong, and then we go after him because obviously this is wrong, is that preemptively they will use data analytics to try to find out, hey, whoever in the society is off, and then maybe there's something wrong, and they will basically, through the use of algorithm, trying to detect weird profiles, and then they will drill down in this. And you know how it happens with video cameras detection,
Yeah.
recognition, facial recognition in the US. If you're black, you're a criminal by default because the camera is biased. And in the digital, in the financial world, it's the same, right? So our first use case is there. It's on a financial transaction because it's a simple message. You're broadcasting a transaction, and the machines that they're going to use to analyze this will be so much biased that we need to have these data which is anonymized.
Okay, I'm gonna do a mix of questions from the chat and also from mine. So the first, this one should be easy. How much does it cost to send a simple message via NIM's mixnet today?
So right now, today, the network is free to use, free to play, right? So it's
Okay.
free, uh, but it is meant to be paid for, right? It doesn't mean that you will have to pay as a user.
Yeah,
So there will
that
be
was my second question.
there will be a lot of use cases where the users can be subsidized by someone, right? So if I design an application like Signal, and I provide a lot of clients on people have connect on Signal with the phone. If I'm Signal and I buy those credits beforehand, I can push them to the client, and they don't see it. They benefit from NIM, but they don't have to pay directly themselves, right?
But can I then DDoS your network and force a huge cost on you to make it unusable
I
for
mean,
others?
that these are the kind of things the people will have to find out. Right now, we're
Okay.
building the building blocks, but yeah, you have to be careful on these kind of things.
So Cheng also asked. Cheng is our founder, by the way. Where's the
I check.
data of NIM past stored? Like the example you showed. Where is the data stored?
So for the paste name, so
Yeah, paste name. Yeah. Sorry.
paste name is a very specific service. Is that this is a community member, and I think some of the guys are in the chat right now. It's a service where someone has a backend, right? Someone has a web server, and on this web server, there's a backend with a database. So that's a very centralized thing.
Yeah.
And they are providing a web interface where you can interact with this backend. What is interesting is that the service itself of me sending a message and storing it in the backend, this is very centralized service. The message is hosted by PaceNIM, but the communication between my computer using my browser and the backend happens through NIM. So there is a client running in my browser, and there's a client running on the backend, and my browser and my client are using the NIM network instead of using clear TCP/IP network to connect to each other.
And like so, a related question. So that what is stored and transported is the data itself. It's not a hash of data.
No, it's the actual data in packets, in Sphinx packets. So, like I said, the 8K. Right now, I think that the size is 8K. These are 8K packets which are sent, and the mix node, they are not storing this data. I mean, they're not supposed to store their data. They just push it, right? There is, I mean, that's what I do.
Okay, great. So another question that came from our friend Ponto is like, there's always a question of scale and decentralization, right? You said you have like 240 mix nodes in total. Um, how do you handle the ideal number of mixing nodes versus the throughput of the network, right?
Yeah.
How do you preserve the decentralization and the anonymity set and the scale at the same time?
Yeah. So that's future development still right now, because the current number is like manually fixed, right, in the system. But we can change it. So we can put less and we can put more. And what will happen is that there is a model which has been designed by Claudia, basically, where we can measure the level of anonymity in the network, and the level is based on the amount of traffic that go through and the available bandwidth. These are like and the delay that we put on the packet. So um, the the more there's traffic inside, the more we can reduce the delay. We can make the computer the network more speedy, and still provide the same level of anonymity. Um, if you're only few people who are using the mixnet, then you need to slow down much so that it's really well mixed, right? And the same for the size, the bandwidth is that if you have a too big bandwidth, too many computers, and then it's like a river, right? If the riverbank is too large and there's a flow of water, you can walk around and you can see, oh, there's a bit of water there, there's a bit of water there. So you need to keep a constant level of water. So basically, the more traffic comes in, then you can add layers of nodes, or you can add, I mean, one computer on each layer. And then if the traffic goes down, then you could actually reduce that to keep a level of traffic, so of traffic which is sufficient. So we have this concept of the active set of computers, and we have the concept of the non-active set, which is waiting, but they're ready to jump in when needed. So right now, this number is fixed by hand, but then at one point it will be kind of like automatically done by the system based on the actual amount of traffic that will go through.
Great, great answer. Thank you. Like, what does Montel is asking? What does one need to host a node, the mix node?
So a mixed node is a very small machine, so it's not very big in terms of like hard drive, very small.
So a Raspberry
CPU.
Pi could work.
Maybe, yeah, maybe, but still, there will be well, it's a CPU based system for now. If the network grows, it might go towards more specialized hardware. But right now, CPU is fine, and it's basically network and CPU. So just like taking data and decrypting and moving it up further. So it is what is mostly required is low latency services. Like you need to have fiber at home, or if you want to compete, right? If you want to be in the top, because all the mixed nodes, they compete to each other to attract delegation and to gain reputation, and so they compete on availability, on latency, and also on transparency of the team that is working on it. But
Uh,
the,
can
the,
you?
the
Yeah,
hardware itself is very small. Yeah.
it's perfect. It naturally leads me to my next question, and I'm gonna mix it with the one from Oheka that you probably know. Uh, can you talk about a little bit about the NIM, the token? First, how does it work? Like, who pays for usage? What are the incentives? And then he asked why you chose the Cosmos blockchain to develop your own chain, right? Which is called
Yeah,
Nix, if I'm correct.
exactly.
So can you just tell us a bit about the token itself and the tokenomics, let's say,
So indeed, yeah.
incentives?
The token is a Cosmos chain. We have our own Cosmos chain, and so first the token, right? So um, uh, we need a token, and that's one of the big criticism of Tor and some other system is that uh, in order to maintain an infrastructure, and the infrastructure has a cost, right? And if you have a totally open and non-incentivized infrastructure, then there's two factors which are incentivizing the Tor infrastructure. One is altruism. So I'm a good person, I feel good, and I'm happy to dedicate resources to the Tor network. Cool. It's actually a big part of the network. And the second is that, oh, I'm an evil person. I want to attack the Tor network, and so I put resources because I have an interest of attacking the network and de-anonymizing people. So I'm the NSA, and I need to de-anonymize people. So I would put effort, and it has a certain cost, which is acceptable for me to attack this. So there's a failure here, which was okay for some time, but now we have this way of doing, which allows us to explore business model. So the token here will be used in different ways. The first way is that our blockchain, inside the blockchain, there is one main smart contract, and this smart contract is actually the central, somehow there's a new piece of centralization there. It's a centralized um, directory service of the NIM mixnet. So obviously, this mixnet, this smart contracts run on a blockchain which is maintained by about 30 validators. So it's much more diverse than the directory service from NIM, which has from Tor, which has about 10 servers, which are all managed by the Tor Foundation. So here you have this service, and in order um, register on the service and to declare your node onto the mixnet, well, you need to make a small transaction there. So this is what is called bonding. So you bond your mix node in the smart contract, and at the same time, you provide a payment address where you will receive your rewards. So
It's like a handshake.
whenever the system is paying reward for people who are active in the network, every epoch, it's every hour, then you actually it's paid on the address you declared. So you can bond and unbond your system. So it's like registering your mix node in the network. You need a small transactions, and then the people who are token holders, who are part of the whole ecosystem of NIM, they say, well, uh, I'm the one who's giving the reputation. So I'm buying some token, I'm getting some tokens, and I'm putting them, I give the reputation to one specific team, let's say the No Trust Verify team, shout out, yes, guys.
Yes.
And putting the tokens there, and we give them the reputation that they need to be always online, and I will get a share. I mean, actually, uh, and I will get a share of the rewards that they are generating for the network. For them, it will go to me. So I'm participating, and I create this the thing, which means that when someone wants to attack the network and wants to set up multiple servers and be active in there, he needs to compete with all these nodes which have reputation. So I would need to buy a lot of tokens to have enough nodes. And obviously, if the prices then starts to pump, people who are already on the place will stick to their position. So you have this all reputation game, which is part of the element to block to protect the infrastructure from the attack. And then the token itself is that's in, that's what the status is now. And then the token itself would also be used to pay for the service. So if I want to acquire credentials which will open the gates of the mixnet, I will have to have a bit of token that I will give to the validators, and I will sell those. I mean, I will buy credential with those tokens, and that will give me a certain amount of bandwidth in terms of gigabytes. So this we have to see a bit how it will go. So the price dynamic will be change in the future. So now why Cosmos? There's a lot of reasons why Cosmos. So the project of NIM started in 2018, really like really when we thought about, okay, let's have a blockchain with it. 2019, what choices did we had, right? There was Ether, or Ethereum, let's say, Ethereum, which was the first natural place to go where these kind of things can be built easily. Um, we were thinking, and still maybe in the future, something like RGB, so like a second or third layer over Bitcoin, which could do the same thing, because we need a token to represent the price, and we need to have these logic where we can bond and unbond the systems and places where people can see what is the map of the network. So all these functions, um, and we also need a set of computers which are running what is called a NIM API. And so anyway, all these functions could be designed on different environment. Could be designed on Bitcoin or with RGB, or on Ether using smart contracts. But they all had drawbacks. RGB didn't exist until very recently. Ethereum was had structural problem with very high fees, so like that would have also made a big problem. And Cosmos was a bit the first one before Polkadot also ever came to provide an SDK to build your own blockchain. And so it allows us to focus on the mixnet and have in 1 month we built a blockchain which is running, right? Uh, with at the beginning a permissions layer. So we didn't put effort in our in the blockchain. We put, because this is something we're not blockchain. NIM is not a blockchain designer. It's a mixnet designer, right? That's the so let's put the money of our investor and of our community who's investing us in the mixnet. And so we chose SDK, which allowed this very fast work. And then also, the Cosmos SDK or the Cosmos chains have this specific, which now you can see on other chains, where you can just run WASM WebAssembly program. So if we design something in Rust, we could just compile in WASM and just or CosWASM in this case, and we can upload it on chain and have very efficient and very gas efficient ways to run our codes in the blockchain. So and then the Cosmos environment allowed us to interconnect with the rest of the Cosmos, or the Cosmos interoperability capabilities allowed us to interact with the rest of the Cosmos universe, to be able to make a bridge to the Ethereum world. And our token is also available on Ether, thanks to the community that of Cosmos with what they built. So basically, we see a lot of benefit right now of using Cosmos. Is Cosmos chain going to be the ultimate way Mixnet will run? Maybe not. Maybe that's we'll see. But right now, I think it's like what the best logical and business and technical choice that we had. I think we chose the one that allowed us to focus on the Mixnet rather than building a new blockchain for ourselves.
Wouldn't it make it more resilient to be actually multi-chain, to have the token on multiple chains
Yeah, no,
over
that's
time?
so over time, that's definitely something. Yeah, that's one of
Okay.
the options. And I think I think this is a general trend that we will see. It started with stable coins. I think this is I think people were a bit troubled with it at the beginning. Obviously,
Yeah.
stable coins have all their flaws, but what we see a movement of like stable coins becoming multi-chain, right? And
Yeah.
I think that projects like NIM, which are making something else, an infrastructure or whatever, something else, and actually needs a token for some economical things, will actually benefit from being present in different chains. Yes. So for me, it makes totally sense that such project, because we're not we're every chain is a home. It has its own ecosystem, own
Yeah.
community, own economical value. And if you want to provide the best service to the internet, you have to be present to the chain. So the internet of the internet, the network of networks that we know as internet, obviously the blockchains of blockchains, or the interconnection of blockchain is happening. It will happen also through tokens, which
Yeah.
actually will take place in many blockchains. Oh, yes.
So until your NIM is coming to Alephium, to our
Yeah, why
future
not?
soon to come bridge,
Yeah.
uh, my question now is okay. You've talked about this in your presentation a bit, but like, what is the low hanging fruit for people on Alephium who are building on Alephium or mining Alephium, um, to leverage NIM or to contribute to NIM? By the way,
Yeah. So the
uh,
very
s-
low hanging fruit is actually to use to create what we call service providers. So it means that you would have a Alephium node, and you would run an NIM client next to it, and basically you could expose uh, the the API. I mean the RPC of the node through NIM, which means that you can have two things. Either the node can communicate with other nodes through NIM, and so like kind of having this Alephium network of computers which disappears, becomes anonymous.
yeah.
Or very simple is that if in the wallet you have to add the functionality of the NIM client in the wallet to talk to the node, so between the wallet and the node. And so what would be cool, if I don't know if it already exists in the Alephium wallet, but
It is. it
Have
is
a
a work
stocks.
work in progress. It's one of the things we
Okay,
have been
so a lot
actively
of wallet,
investigating.
a lot of wallets. So a lot. You have two options. Either you can include natively inside the wallet, you can include
Yeah,
an client. It's a Rust package, so you can easily add it, and then someone can um, turn on, turn off the NIM communication, and on the other side, it will connect to a node, an RPC, which is talking on the NIM client. So that's one. Or what you could do in the meantime is design a standard generic SOX5 interface in the wallet, and that would communicate through the NIM Connect that I showed you on the website.
yeah.
And then you could have a service provider be on the other side, which is running a gateway with, sorry, which is running a service provider with Alephium server. And that's what we did for Monero. Basically, with Monero, we have a one dedicated service provider, and you can connect the Monero D through the NIM Connect to the NIM network to a server on the other side of the.
Are there others than Monero already who have that
Yeah, we have
functionality?
Electrum, and we have Electrum, so on Bitcoin, and we have also Green Wallet from Blockstream. This is also on Bitcoin, and we tested. So this is more like a demo MetaMask over Ethereum.
Awesome. And like that leads me to the probably the last question from the community. As a Bitcoin OG, what's your vision of a proof of work based layer ones versus Bitcoin based layer twos? Yeah, it's
Can you repeat that question exactly?
yeah. What is your vision of proof of work based layer ones
Yeah.
versus Bitcoin based layer twos? So
Okay.
it's
So
a
like,
little bit like Alephium versus a GB or things like this, maybe.
all right, all right, all right. Yeah, Alephium versus RGB. That's the kind of.
I mean, that's how I understand it.
So
Although I don't think it's versus, it's just two
yeah.
ways of accomplishing the same vision.
Yeah, I mean, I think everything has its place, right? So Bitcoin Core, I mean, the core of Bitcoin mainnet,
Yeah,
is a very specific a tool, right? And this tool is based on a industrial process. So you're transforming energy into hashing power, and you have this link with energy and with electricity, which is very specific that only Bitcoin can do, right? And no one else in the ecosystem does that the same way. Um, and and then you're building the financial industry, or not just the financial industry. You're building the value industry, or the value environment on top of this, on top of Bitcoin. And you can scale Bitcoin in many different ways. As you can scale Bitcoin inside Bitcoin, make it better. You can scale Bitcoin on top, creating layer one, layer two, layer three, whatever, how many layers you want, based on the needs. And you can scale on the side, which meaning having, of course, you can have like side chains, but you also can have other environment. Like for me, how I see Ethereum, even though it has a very distinct now model because it's based on proof of stake, which is more capitalistic, or is capitalistic compared to Bitcoin, then it's still an extension of Bitcoin, because you can represent things there that wouldn't make sense to represent maybe in Bitcoin. That's why, for example, NIM is represented on the Cosmos chain, which is an EVM type of chain,
yeah,
because uh, right now it's would be still too. I think the bit the crypto industry in its whole is still too much immature, that using Bitcoin directly wouldn't make sense. We need to find other dynamics. So what I mean by this is that having I mean, proof of less work and sharded transaction-based system, uh, having those other layers which are scaling Bitcoin on the side, with UTXO based system. The advantage is that you can communicate better. So Bitcoin communicates very hard with EVM systems because they're designed a different way.
yeah,
But within the environment of, if you stay in transaction based system, then you can keep this kind of like communication, and you can mix some more things. What is interesting for me is that in a visionary point of view, right? In vision. So Bitcoin brings something essential. It's a new accounting system. So we talked
Yeah.
about it already, but um, Bitcoin is a triple entry accounting system. So if you guys don't know, and we're not going to go much into the detail, but if you don't know what
And
is
like we're here for the next 3 hours, anyways, so
okay,
you can go.
exactly. So if Bitcoin is key because it's a fantastic and completely underrated. Now people start to realize, but a completely underrated invention, and it's an accounting invention. Also, it's a machine that makes triple entry accounting. Um, and um, and if you're looking at EVMs are built on the logic of Bitcoin, but they don't have the same rules. So they're not a pure triple entry accounting system. They can extend, you can do other things, but they're not pure. What is interesting with if you stay in the transaction-based system and you interact with Bitcoin, then you can still build and continue to make that main triple entry accounting system better, and you can gain efficiency and you can do some cooler stuff and maybe some other tokens, whatever, using that
Yeah.
core system. So I think it's all of them are worth it, and I think there will be also some crazy connections. You will have RGB running on Lithium at one point, whatever,
Yeah.
and
As
tokens.
you, yeah, as you
And
know, we're big believers in UTXO based
yeah, yeah, no,
systems.
no, of course, yeah, yeah. No, me too, me too. And I think the EVMs right now have, even though we're using one, right?
Yeah.
The amount of like hacks or misconfiguration of those EVM is so high. I mean, you get hacks every day because there's like a code problem, redundant reentrancy, hack,
Yeah.
whatever. Uh, those EVMs are very susceptible to be hacked, and right now in Bitcoin is like the hacks are possible, but it's at the user level, right? Getting your seed
Yeah.
compromised and this kind of thing. So it's a different kind of risk, and yeah, I think people who will master UTXO based systems will be stronger in the economy of the future.
That's awesome. Like let's do a little bit rapid fire questions so we
All right.
get to the end. I want to free you. I want to free the audience, but at the same time, I enjoy this discussion a lot, as always. So it's a bit of a balancing act. First, we have a question that's an easy one, but it was asked. I know the answer, but I will ask it to you. I think today a lot of exchanges have started delist privacy coins, like Monero. So how can those who care about privacy guard against this from happening and ultimately survive against crippling regulation? So first, the question that is not asked there, that is easy to answer, is actually, is NIM a privacy coin? I think the answer is very easy.
No, the answer is no, no, no. NIM is not a
Yes.
privacy. It's a standard Cosmos token, which is very transparent. We could make it as a privacy coin, maybe in the future, using zero, with
Uh,
using rollups or these kind of
CK
things,
Sync or yeah.
whatever. But no, no, it's the network. It's the network is providing anonymity, but not the token.
So what about the question? How do you, if you squeeze the privacy coins outside of the system and the connection with the system, how do you manage privacy if for some reason states decide that NIM mixnet is bad and they want to squeeze it, they're gonna squeeze the token, right? They're gonna
Yeah.
squeeze it out of
So,
the
so
exchanges.
yeah, of course, that's a risk, and I mean, we at NIM we protect ourselves, right? We try. We have like some strategy to protect ourselves, and one of them is to be very clear that we are on the infrastructure side, on the communication level side, and Tor is not banned. VPNs are not banned. I mean, there's a lot of communication networks which give privacy, and actually pretty good privacy already, which are not banned. So what are the legal tools you would have to ban NIM compared to those ones, right?
Well,
So,
there could be an
so
argument that Tor isn't banned because it's observable, right?
yeah, yeah, there could be an argument, but Tor is already if you look at the case of ProtonMail, you had this guy
Yeah.
who used ProtonMail and was caught by the French police or by the Swiss police in this case. If he had used Tor, he would have been safe, right?
Yeah.
And ProtonMail was providing a Tor exit node, so I mean a Tor hidden source. So there was a chance he didn't take it. So uh, what we need, so the other way we want to protect this is to make privacy or using these kind of system um, available everywhere. So it should be normal for in our systems. If you just develop a website, actually it should go run through Node also, like the paste name type of site. Because if you have so many people using privacy system, then becomes normal. And the financials laws are always made the same way. Why was Tornado Cash a target? Because they were designed to make anonymous transactions. That was the only use of it, right? To mix the transaction. If I want to make a normal transaction with someone, I don't need to use Tornado Cash. But if suddenly to visit a website, to just get an information, send a message to my friend. I use the same systems then to hide a transaction. Then is it's impossible to go against this. So this is exactly what happened with HTTPS back in the early 2000s, something like this. The, there was a lot of websites which are HTTP. There was no security. And at one point, the browsers and the big infrastructure says, we stop with this shit and we push everyone to use HTTPS. And some governments did say, hey, no, we're not going to be able to surveil everyone. But then it became the norm. And since then, no one is questioning the fact that your website should be HTTPS. And it's actually became cultural. HTTPS is the norm, full stop. You're not a criminal because using a HTTPS. So it has to be, we need to build the same thing. And because people are going to move more and more into crypto or into payment systems or into system financial systems which are digital, and to protect just they will be using system like names like name.
Yeah.
And so at one point it will be so much available everywhere
Mm.
that you won't be able to stop that. That's the
Yeah.
strategy.
Amazing. So one day I will have the option in my iPhone to just
No, you
anonymize
will.
all traffic.
You might not even see it. It will be
Yeah.
anonymized by default. Yeah.
So okay. So last question is a bit about you, and because I mean you've been a passionate advocate of decentralization, the ability to do anonymity, and with a sense of it's a political question, right? So now that you've been 10 years in crypto, more or less, right? What's your view on decentralization? Because from the time we had like these crazy discussions about the future, now we have there's a track record, right? You have seen the trajectory of decentralization or potential decentralization happen. So how do you look at it? Are you worried? Are you thinking we're on the right way? Obviously, you're still building, so you have to be believing in it. But like, can you give us a little bit like as a last as a
All
going
right.
out question,
So two things. So I'm a
a
very,
vision?
you know me. I'm
Yeah.
a very positive person all the time. Otherwise, I wouldn't be building stuff, right? But I think two things were made much more clear these last years. Is that I knew I was already convinced of them, but now I see them, which is a bit different. One is the time that it needs to build all of this. And it's a generational change, right? So people who are in the room, we're the first generation building this, right? There is every generation is about a 20-year gap. That's what you see. We're in the middle of only the first generation of people who are going to build the world that is going to use crypto. And it doesn't mean that it goes the right direction, but it means that there will be mass adoption at the end of the cycle. So we might see it when we're really, really old, right? But why is that? It's very simple. There's the builders. We are part of a group who grew up outside of internet. Now most of us are grow up inside internet, but our parents were from outside the internet, and none of our parents and none us, we grew up with cryptocurrency. There was this concept that did not exist in school, right? And or at the university. So now uh, we are building that. My kids are born in Bitcoin. I mean, they didn't know they don't know the world before Bitcoin. They were born after Bitcoin. So those kids, the next generation, the one that will start in 10 years to be active, they will start their life knowing the concept of cryptocurrencies. Everyone at school, everyone talks about it, right? That's the normal stuff. And they will start playing it, using it in the world, in the business, but they won't, they will have to invent to build the cultural elements of it, because we cannot give this to them because we didn't grow up with it. So so we're trying to do like how to make your 12 words and 40 the 40 words mnemonic,
Yeah.
making signing ceremonies. We're learning this at our age. It's very, for them, they will learn differently. And then there will be their kids, and their kids, for them, they will have grandparents and their parents who've been using crypto. And for them, crypto, whatever it looks like, will be just normal. They will even not even think about it the same way people now today don't think about internet. That's natural. I mean, only the old people are still saying, "Oh, internet is changing the world." Really? Oh, we thought it would. Yeah. So okay. So mass adoption will take 60 years, and we're only 10 years in. That's the first thing. The second thing, which I'm really aware of, and it's terrifying, is that look already how much disruption internet after 60 years, because internet has a 60 years or more story already, how much disruption internet is causing right now with just algorithm getting better, and those LLM or this generative content, whatever, is just one extra little step in front of all these disturbances. But now we're just at the beginning, 10 years in. Internet, we're 60 or 70 years in, right? It started in the 70s until now. So yeah, it's almost 60 years in. Now we're only 10 years in. We're touching not the communication, we're touching the value. And so uh, the notion of value in the society is critical. So the way that this value moves peer to peer, moves in a different way, is going to radically transform the society. And the problem is that before it gets good and before it goes into the utopian way, it will get bad, but really bad. So I think, for example, that and I will maybe say something controversial right now, but for example, the war between Russia and Ukraine has some technological element, cultural element made, which were induced um, by the way that communication is working differently. The fact that the Capitol was stormed in the U.S. was the technological element, the communication element of it was core. So now imagine those things where money is involved, right? So money is power. Power is going to be communication is also power, but money is more power than communication. So the struggle will go very bad, and yeah, I'm really worried now about this, and that's why we need to protect ourselves and build privacy systems as fast as we can. But that's are going to be this is our exit plan, right?
I love it. I mean, you've summed up crypto in an amazing way. You started by saying, you know me, Vlad, I'm an optimist, and then you said it's gonna be really ugly. It's gonna get really bad, and in a way, everything we're doing is a little bit like this. So to protect ourselves and to make society at the same time, we need to not trust everyone, but because we love everyone, we need a system that we can trust. So there's these contradictions there.
Yeah. And also
We're not
to
gonna
keep
solve
saying,
them today. Huh?
and also to keep saying yourself, myself, that this is being part of this thing. I'm not a builder in the sense of like coding these stuff, right? But being part of this and pushing this direction and being a legal builder and talk about this, it allows me personally, mentally, to remain sane. That at least I'm trying to do something, right?
I mean, I feel you. I mean, that's the reason I'm in this, that I'm discussing those things for 10 years now. And I have had some great conversations with you. And I really, I will thank you now. Otherwise, we're going to keep
Thank
on for
you.
the whole
Yeah,
night. We'll have you again once soon, I
sure.
hope. Um, So I want to thank you for coming. I want to thank your team for helping us relay the event. I want to thank Jean, who has handled this stream masterfully, and I want to ask to thank the community for their questions. It's been honestly, it's been a great experience for me. I hope it's been a great experience for you. I hope you will come back soon.
Yeah.
On our side, Alephium will have plenty to talk about in the coming weeks. We'll talk about the hackathon. We'll talk about the ambassador program. We'll talk about the bridge. We'll talk about the mobile wallet. Like we usually do that in Discord every day and on Twitter. So stay tuned with us. Uh, Thanks a lot for coming again. Uh, and now we're gonna shut up this podcast and let you go enjoy your evenings, which is one of the first on your evening. Thank you,
Thank you.
guys.
Bye bye.
Bye.
Cheers.